Hello students. So today we are going to learn our first chapter named sets. So do you know what is a set? So we have learned about different collection of objects like the collection of toys in your bag or the collection of dresses in your closet, etc. So are all these collections well defined? Okay, so if our collection is well defined, then we can say that is a set or that collection is a set. So, what do you mean by well defined, or what is the actual meaning of well defined? If you are able to tell an element belong to that set or not with certainty, then it is well defined. For example, if you have been asked like who is the topper in your class? So everybody will be having different answers, right? Because there is no specific criteria. Similarly, that set is not well defined because you cannot say who is the best one. So, in that manner, or that is an example of well defined set, or that is not a well defined set, but that is a criterion by which you can understand it is a well defined set or not. Similarly, set is a well defined collection of objects. For example, the set of alphabets in English language. So that is well defined because we know that only 26 alphabets are there. So if somebody is asking and if the number 1 belongs to the alphabet, we can tell obviously not, because A to Z are the alphabets belonging to English alphabets. Okay. So a set is a well defined collection of objects, and you can say it is a set or not by seeing some collection, by seeing this definition. So, before further proceeding about sets, you have to know our number system, which you have learned in your previous classes. Okay. So, I think you know about natural numbers, whole numbers, integers, etc. But you should be crystal clear about all those things before learning about sets. Okay. So, we can just brush up all those things and okay. These are natural numbers, integers, whole numbers, rational numbers, etc. So on. Okay. Natural numbers means what? 1, 2, 3, etc. All those numbers comes under natural numbers. And if we add 0 along with natural number, then it comes whole numbers, or it is called as whole numbers. If we add the negative numbers along with this whole numbers, we get integers. Okay, so natural numbers are represented by n, then whole numbers are represented by w, integers by z. Okay, so all these things you have learned in your lower classes, in your basic like 6th or 7th, etc. But you have learned about rational numbers in your 9th standard. I hope you know about them. And what is a rational number? Rational number means it is a kind of number in which numbers are represented in the form a by b, where a and b are integers and b should not be equal to 0. Okay, so those are rational numbers. See, and it is represented by q. So if you are asking me, tell me an example of rational number, you can write it like 2, 3, 4, etc. Because all these are having denominator as 1. So you can say all the integers, whole numbers, natural numbers are rational numbers because all these numbers will be having 1 as the denominator. And a typical example of rational number means you can write 1 by 2, 2 by 4 or something like that, or minus 1 by 7. All these are rational numbers. Okay, negative numbers will also be there. There is no restriction for writing negative numbers here. And then comes irrational numbers. So have you heard of irrational numbers? What do you mean by irrational number? The numbers which are not rational. Okay, simple. But irrational numbers means like root 2, root 3, etc. Can you classify these numbers somewhere in rational numbers? Yeah. Pi and root 2, root 3, root 5, etc. All these are examples of irrational numbers. Okay. Then is real numbers. So next classification is Next classification is real numbers, but this rational and irrational numbers comes under real numbers. See, I can write it like this. Real numbers, it can be classified into two. Rational numbers and irrational numbers. Okay, so rational numbers means, as we have discussed, natural numbers, whole numbers, integers, all these comes under rational numbers or P by Q form and Q not equal to 0. Then is irrational numbers. Irrational numbers means what? All those real numbers which are not rational. That is irrational numbers. Then you will be learning about complex numbers in future. Like in this year itself, you will be learning about complex numbers. But those real numbers which are not rational are called irrational numbers. And apart from this real number system, there is another number system called complex number system, and this real numbers comes under complex numbers. Okay, so this is the largest number system, and all real numbers are complex numbers, all rational numbers are real numbers, all irrational numbers are real numbers. Okay, so root 2, pi, root 5, etc. All these are irrational numbers. Then, what do you mean by z plus? As we all know, z means the set of integers. So, if you are adding a plus sign or a positive sign, then we can say it is a set of positive integers. Okay, so what are positive integers? Positive integers means natural numbers. Like you will be taking only 1, 2, 3, etc. All these are positive integers, or positive integers means natural numbers. Then Q plus, positive rational numbers. What do you mean by positive rational numbers? All those rational numbers where negative numbers are not included. Okay, so positive rational numbers means negative numbers will not be there, 0 will not be there, and all other rational numbers in the form P by Q where Q not equal to 0. So that is positive rational numbers. Then R plus means positive real numbers. All those numbers except negative real numbers and 0. Then R minus, negative real numbers. Negative real numbers means all those numbers, all those real numbers except 0 and positive real numbers. That is negative real number. So you should be having a clear knowledge about all these number system. Then only you can do the problems in sets. So next we are learning about set or set theory. As we said, set is a well-defined collection of objects. For example, yes, we have listed an example. The set of English alphabets. Then, what is another example? All those number system. Yes, we have learned about all these things. So, set of natural numbers, set of integers, set of whole numbers, set of rational numbers, all these are examples of set. Or we can write set like this also. 1, 2, 3. This is also a set. This is well defined because we can say what are the elements of this collection in a clear manner. Okay. See, examine these collections. Odd natural numbers less than 10, that is 1, 3, 5, 7, 9. Okay. So, odd natural numbers less than 9 means, less than 10 means there will be only 1, 3, 5, 7, 9. If we choose any other number, either it will be greater than 10 or it might not be natural number or it might not be odd. Okay. So, odd natural numbers less than 10 means only 1, 3, 5, 7, 9 comes. Then the rivers of India. Okay, so this is a well defined set, right? This is a well defined set. Then the rivers of India. Can you tell the rivers of India as well defined? Because a river in our country, there are several rivers and you cannot say this thing is a river or not, because some rivers might not be having name, etc. So this is not well defined. So we can say this cannot be a set because rivers might be having tributaries. So should we consider tributaries, or should we consider all those simple drains, etc.? No. Or we are having a confusion there. Okay, so that is why this is not a set. Next, the vowels in the English alphabet, namely A, E, I, O, U. So yes, in our English alphabet there are only 5 vowels. Okay, so vowels means that is well defined, or the vowels in the English alphabet are only 5. Okay, so if you got any other alphabet, you can check it is a vowel or not. So this is also a well defined set. Next is various kinds of triangles. Okay, so various kinds of triangles means, is it a set? Of course it's a set, because if a triangle is given, you can see it is what kind of triangle. Okay, various kinds of triangle means, yeah, scalene triangle, then equilateral triangle, then right angled triangle. Yeah, all these are kinds of triangles, all are different types of triangles, and we know how many types of triangles exist. Okay, so this is also a well defined set or a well defined collection, and hence it is a set. Next, prime factors of 210, namely 2, 3, 5 and 7. Okay, so if we consider this number 210, there will be several factors, and there will be a finite number of factors. In that, there are only 4 prime factors. So the set is well defined. Okay, so you can say if you got a number, it is a prime factor of 210 or not, you can check. So this is also a set. The solution of the equation x square minus 5x plus 6 equal to 0. See, this is a quadratic equation, and as you know, quadratic equations has only 2 solutions. So there will be only 2 elements in that set, and we know which are the elements. So we can say it is well defined. Okay. Then the following points may be noted. Objects, elements and members of a set are synonymous terms. Okay, so this is what I have mentioned. You can consider a set 1, 2, 3. So in this set, objects, elements and members are same. We can say 1, 2, 3 as members, objects or elements. Okay, so these are the elements, members or objects. Sets are usually denoted by capital letters A, B, C, X, Y, Z. Okay, so sets should be denoted by capital letters only. See, I have denoted it with A. Always a set is denoted with a capital letter. Then the elements of a set are represented by small letters. Okay, so elements, see, this is an element 1, 2, 3. 1 is an element, 2 is an element, 3 is an element. Similarly, while writing an element, that element must be a small letter, or we should represent that element by a small letter. Next is representation of sets. How can a set be represented? Okay, a set can be represented in a roster form and set builder form. There are 2 kinds of representations of a set. So first one is roster form. What do you mean by roster form? Roster form means you can write the elements of a set in a bracket separated by braces. Okay, so as I wrote earlier in our previous slide, that is 1, 2, 3. So this is a roster form representation of the set, because I have written it in the curly brackets, and while writing the set, it should always be in the curly bracket. And the braces, after the braces, you should check the commas. All the elements are separated by commas. Okay, so in roster form, all the elements are listed and are being separated by commas and enclosed by curly brackets. Then the set of all natural numbers which divide 42 is 1, 2, 3, 4, 1, 2, 3, 6, 7, 14, 30, 21, 42. Yes, these are the factors of 42, and this is the roster form of the set. Okay, so I can write it like a curly bracket separated by commas. Then in roster form, the order in which the elements are listed does not matter. Okay, so if I write 1, 2, 3 or if I write 3, 2, 1, all these are same. You don't have to consider the order of the members. Next, the set of all vowels in the English alphabet. The set of all vowels in the English alphabet is A, E, I, O, U. Okay, so you can represent this in the roster form in this way. A, E, I, O, U. The set of odd natural numbers is represented by 1, 3, 5, etc. See, this set is not a finite set because the set is having infinitely many elements. So, they are having dots. Okay, so there will be brackets and the elements will be separated by commas. The dots tell us that the list of odd numbers continue indefinitely, or we can say there are infinite number of odd numbers. Then, see, in this school, what is this set? You are given a word school and you have to write which all letters are used to write this word. So, in the word school, as you can see, 2 O's are there. So, while writing the set, you should write only one O. Generally, in a set, elements will not repeat. Not generally, while writing a set, you need not have to write an element twice. Okay. Then, set builder form. So, after roster form comes set builder form. So, you can write a set in set builder form also. So, what do you mean by a set builder form? All the elements of a set possess a single common property. Okay, so while writing set builder form, you can say there is a common property for all those elements in the set. And if you are writing the set of English alphabets, it can be written like this. Set of all x, it will be read like that. Set of all x such that, this 2 dots means such that x is a vowel in the English alphabet. Okay, so this is the set builder form. And what is the roster form? Roster form is A, E, I, O, U. So you can write same set. These two sets are same. So you can write this in roster form or set builder form. You can write it like this, and this is known as the set builder form. Now consider this example. A is equal to set of all x such that x is a natural number and 3 less than x less than 10 is read as the set of all x such that x is a natural number. Okay, so this is how we read this set of all, the set of all x, the set of all x such that, and then you have to write the common property held by that elements of that set. Okay, then yeah, notations. How do we notate the elements? See, as you can see, I have written a set. A is equal to 1, 2, 3. So, if I consider 4, you can say 4 is not there in the set. And if I consider 1, 1 is there in the set. So, you can write it like this. 1 belongs to A. This is the symbol. This is a symbol for saying belongs to. Or the name of this symbol is known as epsilon, and it's a Greek symbol. So this Greek symbol means epsilon, and we are writing this epsilon to denote this element belongs to the set. Okay, so we know that 1 is belonging to A, and I can write it like 1 belongs to A. Similarly, we can say this 4 does not belongs to our set A. So I can write epsilon and then give a cross, or 4 does not belongs to our set A. I can write it like this. So these are the notations, and if we choose whatever set we choose, we can use this notation to check or to write that one element belongs to that set or not. Okay. Next, write the solution set of the equation x square plus x minus 2 equal to 0 in roster form. So you have been given an equation and you have to find the solution, and then you have to put it in the roster form. Okay, so what was roster form? Roster form means those sets enclosed by braces separated by commas. Okay, so first of all I have to find the solution. Solution means x square plus x minus 2 equal to 0, and x square plus x minus 2. How do you find the solution? Yes, you have learned it in your lower classes. First of all, you have to check what the sum of what number gives 1 and the product of which numbers give -2. Or I can write x plus y equal to 1 and x into y equal to -2. Okay, so I can write x square plus x minus 2. So -2 into or +2 into 1, 2 and 1. If I add 2 and -1, you will get +1, and if I multiply 2 and -1, you will get -2. So you can write that numbers, or x square plus 2x minus x minus 2 equal to 0, and I can take x common outside, that means x plus 2. Then I am taking -1 outside and it is x plus 2 again equal to 0. Then I am taking x plus 2 common outside, then comes x minus 1 equal to 0. So x can be -2 or x can be 1. So these are the answers. So there is a simple method also. If you are getting x and y like this, 1 and -2, then our answer will be just take the opposite sign. The answers will be 2 and -1. Okay, so we got 2 and -1. Oh, I am really sorry. You don't have to take the opposite sign. You have to write it like that itself. So 1 and -2 will be the answer. You got 1 and -2. So this is how we find the solution of a quadratic equation. Otherwise, you can use the quadratic that formula also. Minus b plus or minus root of b square minus 4ac by 2a. Okay, so you can use that, or if you can find it like this, anyway. Then write the solution in the roster form. You have to write it in the roster form. So roster form means, yes, that's it. -2 and 1. Okay, so this is how we write it in the roster form. Next, write the set x such that, set of all x such that x is a positive integer and x square less than 40 in the roster form. So first of all, you have to find which all numbers satisfy this common property. So they are given it in the, see which form, set builder form. So question is in set builder form, you have to convert it into roster form. So x is a positive integer and x square less than 40. So first of all, you can write the positive integers. What are the positive integers? 1, 2, 3, 4, etc. All these are positive integers. Then x square should be less than 40. So 1 square is less than 40. Yes, 1 square is 1. 2 square is 4, less than 40. 3 square is less than 40, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49. Okay, so these are the, I'm really sorry, it's 6. Okay, so up to 6, these are the numbers whose square is less than 40 and are positive rational numbers, positive natural numbers. If you take 7 square is 49 and it exceeds 40. So you have 1, 2, 3, 4 and 5, 6. This is the roster form. Then write the set A is equal to 1, 4, 9, 16, 25, etc. in set builder form. Okay. So first of all, you have to identify which is the common property. Then only you can write the set builder form. So this question is given in the roster form, and 1, 4, 9, 16, 25. As you can see, this 1 means 1 square, 4 means 2 square, then 9 means 3 square, then 16, 4 square, and so on. So you can, you got the common property, right? The common property is you have to take the square of the numbers, square of positive integers. So you can write the set builder form as, how did we write it? Set of all x such that x, set of all x square such that x is a positive integer. So this is how you write the set builder form. Set of all x square such that x is a positive integer. Okay, that's it. You have to take x square. First positive integer is 1 and 1 square is 1. Then 2 square which is 4, 3 square 9, and you can write it like this. Okay. Next, write the set 1 by 2, 2 by 3, 3 by 4, etc. in the set builder form. So while looking this question, you should be able to understand in which format is this written. Okay. So you can see 1 is added to the denominator. If you add 1 to the numerator, you will get the denominator, and it have been start with 1. 1 is the first positive integer. Okay. So you can write set of all x divided by x plus 1 such that x is a positive integer. Okay, so you got the set builder form. X divided by x plus 1, and x is a positive integer means you should start with 1, and if you give 1 it becomes 1 divided by 1 plus 1, 1 by 2. Then if you give 2 it becomes 2 divided by 2 plus 1, 3, 2 by 3. And there is one more thing. Here it comes up to 7 only. Okay, so you should take up to 6. X should be up to 6 itself. X is a positive integer, and you should check, you should write one more thing. X is less than or equal to 6. Okay, and you should write that property also. And x is less than or equal to 6. Because this is a finite set. In our previous question, this was an infinite set. So you should write only one property. But here, since it is an since it is a finite set, you have to write x less than or equal to 6. Because you need not consider all those elements which are greater than 6. Okay. Then next question. Match each of the set in the left to the right. Okay. So in the left hand side it's written in the roster form, and in the right hand side it is in the set builder form. So you have to match them. First one is, see, PRINCAL. See, this is x is a letter of the word principal. Set of all x such that x is a letter of the word principal. So this can be matched to D. Then x is a positive integer and is a divisor of 18. X is a positive integer and is a divisor of 18. So you should write all the divisors of 18. So divisors of 18 means, yeah, 1, 2, 3, 6, 9, 18. So you can join them. Then x is an integer and x square minus 9 equal to 0. So you should find the solutions of this equation. This means, this implies x square equal to 9. So it is 3 and minus 3. 3 square is 9 and minus 3 square is also 9, and you get 3 minus 3. Okay. Then x is an integer and x plus 1 is equal to 1. Okay. Which is that integer? You should solve this equation. You get x equal to 1 minus 1, which is equal to 0, and you get this. Okay. A simple question, right? Then which of the following are sets? Justify your answers. Okay, the collection of all the months of a year beginning with the letter J. See, what is the roster form? We can write the roster form here. In the first question, I am writing the roster form. The collection of all months beginning with J. First one is January, then February will not be there, March, April, May, June, July, then August, September, October, November, December. Yeah. So these are the 3 months having starting letter J. So is this collection a set? Yes, because this is well defined. The set is having 3 elements. This is a finite well defined set, because you can say an element is in this set or not. because you know the elements in the set. So this is a set. Second one, the collection of 10 most talented writers of India. Okay, is this a set? Collection of 10 most talented writers. See, according to a person, a writer may not be good. Okay, so if a person thinks this writer is good, another person thinks no, his writings are not that good. So person to person, you can see there will be change in the set, because therefore it will not be well defined. Okay, but if we are giving a criteria, like we are asked to choose those writers who have been received a kind of prize, etc., related to books like Booker Prize and all, then we can say you can write down those members who all received that prize. On the basis of that criteria we can write. But here there is no criteria given, and they are simply asking 10 most talented writers. So if one person will be saying one name and another person will be saying another name, so this will not be well defined and this is not a set. Then a team of 11 best cricket batsmen of the world. This is also similar to our second question, because see, nothing is given. Just said best cricket batsman, or in the basis of what criteria, that is not given. So we cannot analyze. See, my favorite batsman may not be your favorite batsman. If I am an Indian, I'll obviously say an Indian batsman. Okay. 11 bets of the world. They are asking about the world. So if I ask a Sri Lankan, he will be saying the name of a Sri Lankan batsman. Okay. So this is not at all a criterion, and you can say this is not a set. Then the collection of all boys in your class. See, the collection of all boys in your class means you can say you know who all are there in your class and who all are boys. You can say that, right? So it's a well defined collection, and you can say this is a set. Then the collection of all natural numbers less than 100. The collection of all natural numbers less than 100. Natural numbers. You can see, you can verify. If you got a number, you can check it's less than 100 or it's a natural number. Both property must be satisfied. Then only it belongs to the set. Okay. For example, if I ask 203, this does not belongs to our set. If I name the set as A, we can say 203 will not belongs to this set. But if I choose 62, 62 belongs to the set. So there is a clear-cut specific criterion for defining this set. Okay, so I can say this is a well-defined collection, and hence this is a set. Then the collection of novels written by the writer Munshi Premchand. Yes, is this a set? Of course this is a set, because you know which all novels are written by him. This is a famous writer, and you don't have to consider other novels. You need to consider only those novels written by this person. And this is a very clear-cut idea. There is a very clear-cut idea given here, and you can understand it's a set or not. So this is a set. The collection of all even integers. All even integers. This is an infinite set. Why? Because even integers are continuing up to infinity. There are an indefinite number of there are infinite number of even numbers, even integers. But since it's well defined, it is a set. And the number of elements of a set doesn't matter for considering it's well defined or not. Then the collection of equations or the collection of questions in this chapter. Okay, is it well defined? Simple. You can look through your book or go through your textbook or this chapter. Then you can count the number of questions. Okay, so that's well defined, and you can see. You will be able to count and you will be able to write down how many questions are there in this chapter. So this is also a set. A collection of most dangerous animals of the world. Is this a set? Because you don't know is it dangerous or not. If you there is not a criterion given. Okay, so this is not a set. This is not a set. Let A is equal to 1, 2, 3, 4, 5, 6. Insert appropriate symbol. Okay. So you have to write the symbol belongs to or does not belongs to in between them. Okay. Our set is 1, 2, 3, 4, 5, 6 and 5 belongs to A. 5 belongs to A because 5 is there. 4 belongs to A because 4 is there. 8 does not belongs to A because 8 is not there. Then 2 belongs to A. 0 does not belongs to A. 0 is not there. Then 10 does not belongs to A. 10 is not there. So this is how we insert the symbols. Okay. Then write the following sets in roster form. Okay. So it's given in the set builder form and you have to write it in the roster form. X is an integer and yeah. So what do you mean by this symbol? This means less than or equal to. So you have to consider -3 also. Since there is an equal to symbol here, you have to consider -3 also. And the roster form is -3, -4. -4 will not be there, -2. Okay. See, if I draw a number line and I am writing -4, -3, -2, etc. 0, etc. up to 7, 6, 7, 8. Then it will be continued like this. And there will be 0 somewhere here. So it will be up to here. You have to consider up to 7. Okay. You need not consider 7. Before that, since it's integer, you have to consider only up to 6. -3 to 6. So -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Do we need to include 7? No, because here there is only a less than symbol. If there is equal to symbol, then we have to write 7 also. So this is the roster form of this question. X is an integer and -3 less than or equal to x less than 7. Then x is a natural number less than 6. Set of all x such that x is a natural number and is less than 6. So what are the natural numbers less than 6? 1, 2, 3, 4, 5. Okay. So you can write it. Then x is a 2-digit natural number such that the sum of its digit is 8. Okay. So the digits can be, see, you have to find those numbers whose sum gives 8. That's it. You know 0 plus 8 is equal to 8. Then 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4. So if you choose this, you get 8 and the number will be 0, 8 and 8, 0. Okay. Then 1, 7. 1, 7 means 17 and 71. 2 is 26 and 62. Then 35, 53. Then 44. So these are the numbers in which the sum of their digits gives 8. So and you have to write all those 2-digit numbers. So which are the 2-digit numbers here? 80 is a 2-digit number, 17, 71, all these are 2-digit numbers. You don't have to consider this one, 0, 8. 8 is not a 2-digit number. So while writing it in the roster form, it will be 80, 17, 71 and the order doesn't matter. As we said, if you write 17, 71 or 71, 17, all those things doesn't matter. 26, 62, 35, 53, 44. There will not be any other numbers whose sum of the digits is 8. Digits are 8. Then x is a prime number which is a divisor of 60. So you have to find a number, you have to find a prime number which is a divisor of 60. So first of all, I can write what are the divisors of 60. 160, 230, then 320, 4, 5, 12, 6, 10, then 7. I think these are the numbers. Yes. So if you find these numbers, if you write down these numbers, you have to check the prime numbers which are divisors. So which are the prime numbers? If I choose these numbers here, I can see this 2 is prime, 3 is prime, 5 is prime. There are no other prime numbers, prime divisors. So I can write the roster form as 2, 3 and 5. There will be no other prime divisors of 60. Now, the set of all letters of the word trigonometry. So how do you find this one? You have to write down those numbers, those alphabets. T, R, I, G, O, N, then O. O is written once, so you don't have to write it again. Then M, E, T is also written once, R is written, then Y. Okay, so this is the roster form of this question. Now, the set of all letters in the word better. Better means B, E, T, R. I think R. Okay, so this is the roster form. So next we have to do the set builder form. Yeah. So it's given in the roster form and we have to write it in the set builder form. As you can see, these are multiples of 3, right? 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. Yeah. So you can write it like that. Set of all 3x such that 1 less than or equal to x less than or equal to 4. Okay, 3 into 1, 3, 3 into 2, 6, then 3 fours are 12. And x should belongs to n, right? From where should we choose n? Choose x. X should belongs to n. We are choosing x from natural numbers and x belongs to n. So this is how we write the set builder form. Or you can write it in another way also, such that x is such that x is a multiple. X is a multiple of 3. X is a multiple of 3 and 3 less than or equal to x less than or equal to 12. So you can write it like this also. This is also correct. Then 2, 4, 8, 16, 32. Yeah. These are powers of 2, right? 2, 2 raised to 1, 2 square, 2 cube, 2 raised to 4, etc. up to 2 raised to 5. So you can write it like 2 raised to x such that 2 raised to 1, 2 square, 2 raised to 5. So you can write 2 raised to x such that 1 less than or equal to x less than or equal to 5 and x belongs to n, right? X belongs to n. I'm sorry. You have to write it in same itself. This much only. You don't have to write this. Yeah. So 2 raised to x such that 1 less than or equal to x less than or equal to 5, x belongs to n. This is the set builder form of this question. Then 525, 125, 625. Yeah. This is the power of 5. 5, 5 square, 5 cube, 5 raised to 4. So you can write it like that, set of all 5 raised to x such that, yeah, x is from where to where? 1 less than or equal to x less than or equal to 4. 5 raised to 4 is 625, and then you should write x belongs to n. X should be a natural number. Next question, 2, 4, 6, etc. 2, 4, 6. These are even natural numbers, right? Even natural numbers. So you can write set of all x such that x is an even natural number. Then 1, 4, 9, etc. 100. Yeah. 1 means 1 square, 4 is 2 square, 9 is 3 square, 100 is 10 square. Okay. So you have to choose all the squares up to 10. So you can write it like this, set of all x square such that 1 less than or equal to x less than or equal to 10 and what? X should belongs to n. Okay. So this is how we do set of all x square 1 to 10. You have to take the square of numbers from 1 to 10. Then list all the elements of the following sets. Okay. So they have given the set builder form and you have to write it in the roster form. Okay. So this is x such that x is an odd natural number. Odd natural numbers means 1, 3, 5, 7, etc. You have to put 3 dots. Okay. So this is the roster form. Then x such that x is an integer minus 1 by 2 less than x less than 9 by 2. Okay. So you have to find the integers between these numbers. So for that, I think you can make it into decimal form. Then it will be easier. Okay. So minus 1 by 2 means minus 0.5 less than x less than 9 by 2 means 4.5. Okay. So you have to find all those integers between these two numbers, or you can draw your number line and you can mark 0, minus 1, 1, 2, 3, 4, 5. Okay, so this is a number line and we have 0, minus 0.5 here and 4.5 here. And you have to take all the integers in between them. So which are the integers? 1, 2, 3, 4 and 0. You have to take the 0 also. So 0, 1, 2, 3, 4. These are the integers in between minus 1 by 2 and 9 by 2. Okay. Then x such that x is an integer, comma x square less than or equal to 4. So you have to find those numbers whose square is less than 4. Okay. And it should be an integer also. So you can write 2 square. 2 square is obviously equal to 4 and you can say 2 will be there. 2 and minus 2 will be there. So I can write 2 comma minus 2. Then if I choose any number which is numerically greater than 2 or like 3. If I choose 3, 3 square is 9 and it's greater than 4. So you have to choose all those integers less than 2 and minus 2 or those integers in between minus 2 and 2. Okay. So then I can choose 1. 1 square is 1 which is less than 4. Minus 1 square is also 1 less than 4. Then 0. 0 square is less than 4. Okay. So this is the roster form. Then x such that x is a letter in the word loyal. Okay. So in this word you have to list out those alphabets. L-O-Y-A. That's it. Then x such that x is a month of an year not having 31 days. So you have to find all those months which are not having 31 days. So I think you know this method. You have to check in which all months you have bumps here. See, January, February, March, April, May, June, July, August. So I usually find this way. Okay, so X is a month which is not having 31 days. So January is having hump. So January is having 30 days. Then February. February will be there. Then March is not there. March, April. May is not there. June will be there. Then July, August. Then September. November. Okay. So these are the months having days less than 31 days. X is not having days, not having 31 days. Okay. So you can find it January, February, March, April, May, June, July, August, September, October, November. So all those coming here. Okay. This is a simple method. I think you have learned in your lower classes. Then f such that x f equal to x such that x is a consonant in the English alphabet which precedes k. So you have to write all those consonants before k. Simple. A will not be there. I is a vowel. B, C, D, E is not there. F, G, H, I is not there. J and K, which precedes K. So you need not write K. Then yeah, this is our set. Match each of the set on the left in the roster form with the same set on the right described in the set builder form. Okay. So first of all, you can see the roster form, you can see the set builder form, and then you can join it with the roster form. Okay. X is a prime number and is a divisor of 6. So x should be a prime number and is a divisor of 6. So what are those numbers? 2 and 3. Obviously 2 and 3. 2, 3. Yeah. This. Then x is an odd natural number less than 10. So which are the odd natural numbers less than 10? 1, 3, 5, 7, 9. Right? 1, 3, 5, 7, 9. This one. X is a natural number and is a divisor of 6. So x is a natural number and it should divide 6. So 1, 6, 2, 3. Okay. Then x is a letter of the word mathematics. So you have to list out the alphabets of the word mathematics. Okay. So next we are going to learn about different types of sets. First one is empty set. So as the name suggests, what is an empty set? Empty means nothing. Nothing is there. So as the name says, empty set means there is nothing in that set. Okay. Empty set. Okay, the set which does not contain any element is called empty set or the null set or the void set. So there are 3 names. One is empty set, then null set, then void set. All these are another different names of empty set. Then empty set is denoted by symbol phi or this symbol. Nothing is there. So these are the 2 symbols used to represent an empty set. For example, yeah, we have given few examples of empty sets here. Let A equal to x such that 1 less than x less than 2 and x is a natural number. So how can you find a natural number in between 1 and 2? Because after 1 the next natural number is 2. We know that. So in between 1 and 2 the number should be in between 1 and 2 and it should be a natural number. How is it possible? No. So there will be no element in that set and it is an empty set. Then A is an empty set because there is no natural numbers between 1 and 2. Then next question, next example, B equal to x such that x square minus 2 equal to 0 and x is a rational number. Okay. So if you consider x square minus 2 equal to 0, you can see x square equal to 2 and x is equal to plus or minus root 2. So either x will be plus 2 or x will be minus root 2. So these are the 2 solutions and they are saying x should be a rational number. That is not possible because it will always be irrational. If we solve this equation, x will be getting an irrational value. Okay. Next one, C such that x, C equal to x such that x is any x is an even prime number greater than 2. Yeah, the only even prime number is 2. As far as now, or up to our knowledge, we have studied only 2 as the even prime number. So there will be no even prime numbers greater than 2 and the set will be empty. Then d equal to x such that x square equal to 4, x is odd. Okay, see x square equal to 4, x square equal to 4 means x equal to plus or minus 2. Then x equal to plus or minus 2 meaning what? X is even, x cannot be odd because a quadratic equation will be having at most 2 solutions, and that solution you got it as plus 2 and minus 2 and it cannot be odd. So all these are the examples of an empty set. I hope you understood. Then finite and infinite set. Yeah. So what will be a finite set? Finite set means that set contains finitely many number of elements or finite number of elements, and then infinite set means there will be infinite number of elements in that set. Simple. So a set is empty or consists of a definite number of elements is called finite set. Okay, so there is one more thing, empty set is also a finite set. Okay, then if it is not finite, then it will be infinite set. Okay, now you can see some examples here. Let W be the set of days of the week. Okay, W is the set of days of the week. Then W is finite. Then W is finite. Let S be the set of solutions of the equations. Then S is finite. See, in these two cases, W is a set of days in the week. So as we all know, in a week there are 7 days and it's finite. It's not infinite. You can count it up to 7. So it's a finite set. Then S be the solutions of the equation x square minus 16. So as I said just now, a quadratic equation will be having at most 2 solutions. Okay. So we can say S is finite. Then let G be the set of points on a line, then G is infinite. That is infinite. If we choose a line, you can have infinitely many number of points in that line. Okay, if I'm drawing a line and you will be having different points. I think we have infinitely many points in a line. When we represent a set in the roster form, we write all the elements of the set within braces. Okay, so if you are writing in a roster form, you will be having brackets. It is not possible to write all elements of an infinite set. Okay, so while writing roster form, if we have written the set of even integers, right? So we have put 3 dots because we cannot list out all those elements because the set is what? Set is infinite. Then 1, 2, 3 etc. is a set of natural numbers. 1, 3, 5, 7 etc. is a set of odd natural numbers. So we are representing these infinite set in this manner. We are using 3 dots to represent they are continuing infinitely. Then this is the set of integers. So the set of integers, set of natural numbers, set of odd natural numbers, all these are examples of infinite set. Then all infinite set cannot be represented in the roster form. For example, you can check a set of all real numbers cannot be described in this form because the elements of this set do not follow any particular pattern. Got it? Because see, whatever be the infinite set, you cannot write all kinds of infinite set in roster form because there is no common property which we can say for real numbers. For example, root 2 is real. Okay. Then similarly, if I choose 1 by 7, that's real. So there are different kinds of numbers and you cannot list out a common property that holds for all real numbers. So we cannot write it in the roster form. Then state which of the following sets are finite or infinite. X such that x belongs to n and x minus 1 into x minus 2 is equal to 0. Okay, so you can say this set will be having 1 and 2. Okay, so this is finite set. This is finite set. Then x such that x belongs to n and x square equal to 4. So this is plus 2 and minus 2. Okay, so this is also finite. Then x such that x belongs to n and 2x minus 1 equal to 0. So x will be equal to 1 by 2, or our set will be set 1 by 2. But we have to see x belongs to n. This 1 by 2 is not belonging to n, or 1 by 2 is not a natural number. So our set will be empty. Okay. So this is null set, and we have learned null set is also a finite set. Then x such that x belongs to n and x is a prime. We have to write all those prime numbers. All those prime numbers means what are the primes? 1 is neither prime or composite, 2 is prime, 3, 5, 7, etc. Okay, this is continuing infinitely because there are infinitely many primes, and hence this is infinite set. Infinite set. Then x such that x belongs to n and x is odd. So you have to find all those odd natural numbers. All those odd natural numbers are infinite. Okay. So we got this is also infinite.